Hello again everyone and welcome back to the main stage as we continue our Electrification in Mining 2024 presentation agenda. Next we're going to hear from ABB's Mesut Ashnagaran, Global Product Line Manager Electrification, and Eduardo Lima, Global Solutions Architect. Their presentation is titled Decarbonization, Extending Electrification to the Pit with eMine, and covers the provision needed for the design of an all-electric mine for future developments. As before, we'll be joined by both speakers for another live Q&A session immediately after the presentation, so stay tuned and have your questions ready. Over to Mesut and Eduardo.
Hi Will and hi everyone. Thanks for joining us today. I'm really honored to be with you to go through the electrification in mining as a subject of presentation today. My name is Mesut Ashnagaran. I'm globally responsible for product line electrification and I'm leading the eMine initiative within ABB.
Hello everyone, I'm happy to be here today. Eduardo Lima, I'm Mining Solution Architect.
Yeah, now talking about the electrification and what is ABB approach these days in the market. As you see in this slide, we are trying to look at the entire subject as a complete uniform way. Means that we think about integration of the entire system from high voltage substation down to a low voltage actually feeder in the field. All these red lines that you see means integration and connectivity between different units, that we have a lot of different consumers in the mine. Mainly, for example, grinding is one of the biggest consumers, or ventilation on demand, pump station, belt conveyors, which is also there are a lot of multiple consumers in the mine, and a lot of auxiliary like power factor correction, harmonic filter, these days integration of renewable energy, a storage system. And as you see on the bottom of this slide is a kind of extended scope of electrification when we think about electrified fleet in the mine area, either in form of underground mining fleet system or in the open pit mining, that we have two different solutions. In open pit mining, mainly focus on the trolley system with rectifier substation, and for the underground mining in the form of the battery equipped vehicle, which will be energized by a charging system. The topic is that that is extension of portfolio, and how at the end we see the system fully integrated with automation and digital, as you see in the right side of this slide, and at the end we have a fully integrated system. But I want to address two different trends which is happening these days in the market. The first one is actually degrading the ore. Degrading in ore is already started for many years, and mining is looked at it as a kind of challenge. Mining trying to use the mines which is actually not so good in grade anymore, and therefore we need more energy for extraction, no more energy for hauling, for actually transport and the processing the items. Therefore we see very soon in the market a jump of the power consumption, which some of the actually research shows up to the 30%. Yeah, that was actually the first trend that we talk about, the degrading of the ore. And the second trend that in last 3-4 years was focus of the mining business was decarbonization. As you see, based on the Paris Agreement, mining business or mining industry is obliged to reduce carbon footprint. We are responsible almost for 4 to 7% of entire greenhouse gas emission globally. But while we have in the left side, we see the problem, in the right side, we are a part of the solution, because we are part of the group to produce actually the commodity which is needed for the electrification of the mine, and actually making decarbonization and helping our customer in mining industry to manage this decarbonization or manage this transition of energy. Therefore, we define eMine, as you see in this slide, is a kind of holistic view and overall view of entire mining electrification system. eMine is a kind of response to requirement of this energy transition. Actually be independent from fossil fuel energy and moving towards electrified system. As you see here, we have the process area, and process area is where that we have the most of the consumer there, and it's a 24/7 operation. It's connected to the main substation, one of the very first items that we are dealing with is taking care of entire power distribution of the system and connected to the unit like power quality solution, which is absolute needs, also for process area and also for a new add-up to the entire system, which is one of them is renewable energy integration, because as we said, by degrading the ore, mines are more in the remote area and they are far from the grid and also infrastructure and need to be independent from energy point of view. As we said, 24/7 operation oblige us also to use a storage system. That's why the storage system also play a quite important role in this equation in the future of the mining. And underneath in this box, you see that the portfolio of the eMine, including trolley system, which is actually energized by a kind of rectifier substation connected to overhead line, and a kind of hybrid trucks run under this system and connected to the trolley, or in form of the fully battery-equipped vehicle, which charged by the stationary charging, or be able also in the point of dynamic point of the energy transmission connected to the trolley system to be charged while it's moving under the trolley system. But what is our approach? How ABB is trying these days to implement the solution of eMine in the mining projects? As you see in this slide, our actually approach to the market is a bit earlier than procurement time. We engage in the project in the pre-feasibility study and also feasibility study in form of fulfilling 3 targets for a customer. First of all, to provide the right technology or correct technology based on our own experience and more or less the kind of solution out of shelf that is actually is proven and is tested in the other projects that ABB executed. The second one is a kind of early standardization of the system, which is also absolute needs in all electric mine these days, and also being able at the end to create a plant-wide integration for entire system, which for us is one of the most important tasks. If we miss feasibility study, there is a chance that we do a kind of front-end engineering design or fit work to able to provide this kind of conceptual design for the customer. Actually, all these 3 targets that I said is not the only the things that we want to do out of this approach. We want to, in the same time, being able to reduce the capex of the project by 25%. And this figure is coming based on experience that many projects that executed in this kind of early engagement and being able to use out-of-shelf solution that is already tested and proven in the other mines to be able to reduce the capex and make the investment more interesting from electrification point of view. In the same time, we have also a task to improve the energy efficiency by reducing the energy consumption. And these days also by focus on reduction of the carbon footprint. We have not mentioned here because very much depends on the operation of the mine. Case by case is different, but we have cases right now out of executed trolley project that our customer managed to reduce up to 90% fuel consumption and reduction of the carbon footprint, which is actually quite interesting figure. We have this approach also for eMine, early engagement and being in the very earliest stage with the customer. We have put already 5 pillars or 5 steps to execute the eMine for the customer. The first approach is ABB portfolio in eMine. We wanted to explain what is actually the possible solution that we have out of portfolio and we can offer to the customer. The second one is a strategic collaboration, how we can create a kind of setup that we can do end-to-end or A to Z solution, what we also call it today, grid-to-wheel solution together with the OEM or truck manufacturer. We said in a very honest way from beginning that we entered to this market that no one can do it alone, and ABB also cannot do this solution alone. We need to collaborate with the other strategic partner, which I try to address in the next slide. In the third step, we try to do a kind of consultancy or mine design, being able to provide the customer a kind of very good overall view of CapEx and OpEx and actually total cost of ownership, that they understand what is behind the all-electric mine and what actually looks like the operation when everything is going to be electrified in the mine, mainly the fleets. And if everything okay and approved by our customer, we go to the area being able to provide the fit-to-the-purpose solution, which we also hope that be able to provide a good service portfolio in the future, stay in the line and help our customer to operate the system. In the second step, we talk about the strategic collaboration. This is actually this triangle model between ABB, a kind of a technical or technical provider as a partner, and the customer. We call it KTS, Key Technical Suppliers. We believe this setup can provide, as I said earlier, grid-to-wheel solution, entire solution without any forgotten interface and very gap and holes that the customer are worried about. Therefore, in this kind of setup, we think about the different type of the partner. It's not the OEM or a truck manufacturer. They could be actually a kind of retrofitter or a kind of mechanical supplier or provider a kind of connection interface. Or one of the important one these days is the mine designer, because we wanted to move beyond electrification of the mine. We wanted to show our customer how it looks like a mine when everything is built based on electrification, which we believe is a bit different to a traditional way of the mine design. And these days, our approach is also together with our partner to take over the entire mine design based on the electrification system. Finally, you see in this picture, we try to create such a landscape for our customer, means providing all the traction item inside the truck. It means the AC to DC or DC to DC or a battery system, which is needed for electrification of inside the truck, and going beyond that, all the complementary system around the truck, which energize the truck, either in form of the trolley system, as you see in the picture, connected to the rectifier substation of trolley, or connected by a kind of, for example, pin and socket, which actually play a role of bringing the energy inside the truck, connected to a kind of charging system, which is supported by a unit, which is a storage system or energy storage system as a backup. Therefore, our goal is to provide such a grid-to-wheel solution, as I said from the beginning, fully integrated without any holes and gap. It's a kind of out of a seamless portfolio with a close collaboration with the truck manufacturer. At the end, I should say that we have 5 goals that we wanted to fulfill in this all-electric mine market out of the eMine portfolio. First of all, we wanted to actually fulfill the interoperability, means able to create a kind of open standard. Everyone can work with that. Our customers should not worry about if they have a different type of the fleet. It should be a kind of open standard, works for everyone, and actually be able to maximize uptime and maximize the productivity of the system. In the same time, we have another goal that we wanted to create the kind of flexibility and mobility for system. A mine is evolving, and our customer during the day, they should not worry about to think about the extra route of the trolley or a different type of the charging system or point of the charging when the mine is evolving. Everything is foreseen from beginning in the design of the system, and it works to the end of life cycle of plant. A third point is actually energy management. By increasing the power requirement, as I said earlier, because of the degrading of the ore and no more energy which is needed, and now because of decarbonization, because each of these trucks, in average, will consume 3 to 5 megawatts, we need actually more power, and we need to actually manage this power consumption. Therefore, being able to minimize the load peak and also being able to plan in a very smart way how we wanted to use the infrastructure and battery storage system is quite important, and also energy management play an important role. The other task and goal that we have in this all-electric mine market is that to provide a right connectivity system. These days, connectivity system or connection interface is quite a bottleneck for all the solution that we have for decarbonization. We wanted to have a kind of fully automated, robust, and also mine applicable system, be able to transfer that power which is created by system to the truck. Therefore, we need to create a kind of open standard there, as I said also earlier, interoperability, in the same time a kind of solution that works in the harsh environment of the mine. And finally, we wanted to, as a 5th task, is that we create a kind of trade-off study between different type of solution that exists in ABB portfolio. We also, in the same time, for moving material from A to B, we have a solution, for example, for belt conveying system, or in case of underground mining, for a hoist system. Therefore, we want that the customer has a kind of trade-off between the different type of the solution. They know at the end what is actually total cost of ownership for each of these solutions. And if they are convinced for electrified fleet, they know that this is the best solution that they have taken. And at the end, you see that this slide, we try to show that this is a landscape that we are thinking as a kind of considering all the points that you need to provide energy to the different type of the trucks, either in form of the trolley system connected to the rectifier substation, or in form of the dynamic point of the energy transfer to the battery-equipped vehicle, or points that you want to actually charge the truck based on the stationary system, and everything looks as a one system, which we call it eMine, and eMine is a kind of response to this energy transition. Thank you very much.
Thank you, Mazert, for the first part. Now you focus on operate a successful all-electric mine. So why that is important? Yes, after you build a successful mine operation, you need to sustain that. And to sustain, we at ABB believe that by integrating electrification, automation, digitalization, hand in hand, you can ensure that you are reaching your safety targets, sustainability targets, and productivity targets. And from now, we are going to deep dive in some of these pillars and show how you can reach a sustainable operation of our electric mine. First, we keep the system connected through 4 pillars: power and process control, power and energy management, electric asset performance management, and mine operation management. For each one of these items, we are going to talk about some use case. First, power and process control. Here we start with one system that integrates power and process control. And why you do that? Because it ensures interoperability and agility when you are controlling your system. By having power and process control together, you have the demand of your equipment and demand of your process hand in hand. When it comes to that, we start from smart relays that you install on your substation. The next point is you have a protocol like IC 62850 driving the communication between different equipments on your feeders. And then you come a level above when you have the control that you open, close your switch gears. But you can do more than that. When you have our electric mine, it will be very important to orchestrate the power supply and the power demand. And then here, the power control, that would be a little bit more advanced when you bring fast load shedding, when you do microgrid control, integrating different sources of energy, or using energy storage, as Mazert has commented, to avoid peak loads during the operations. Let's go for the second one now, power and energy management. When you talk about power and energy management, it's not just about reporting, but that you can work with that data in a way that's proactive. By using the data of your equipment, the utilization of equipment, energy efficiency, you can drive improvements of equipment and programs to improve the energy efficiency. The next step that's very important for our electric mine is forecasting and optimization. By forecasting, you could look after your schedule and see when you need to charge the electrical equipment at the mine, where you are having the more demand of your trolley system at the mine, plus other activities that they are dispatchable, not always running 24 hours. Examples, when you are drilling, when you have your shovel operations, when you are moving equipment at the mine, the watering, pumping. So there are areas that you can play with that during the schedule of the operation. So for that, the power and energy management is very important. A second aspect is about energy supply, because during the integration of renewables to your grid, it will be times of the day that you can consume more from the renewables, times of the day you are consuming more from fossil fuel energy. In these two cases, you need to leverage not only the electricity cost, but as well CO2 emissions, and the power and energy management can support you to reach both targets. The next one that you go for, electrical asset performance management. As you have our electric mine, the number of assets that you have that are electrical equipment is increasing. Therefore, your maintenance strategy for electrical assets cannot be only through preventive maintenance or condition-based maintenance, but also predictive maintenance that will be required to that equipment. That is ensuring that you have power quality, that you keep your equipment running, that your chargers, your trolley, and all the different electrical equipments that are part that is running. So therefore, in the electrical asset performance management, you bring a focus on the equipments that are new to your operation that you need to build know-how on top of that. The fourth, and one of the most important, is the mine operations management. The environment of the mine is very dynamic. You have different mobile equipments, you have crews that are operating that equipment, you have weather changes, you have dynamics of your ore body that change all the time. Therefore, electricity that you are sourcing to that environment becomes a large constraint that you need to work, and becomes even more complex to a mine planner or to a mine engineer. Is the same with maintenance and operations and site manager to take decisions that what brings to you the outcome of production, and at the same time is in the boundaries. So with the mine operations management system, you can do that. You take in consideration your constraints of production as well of the energy source. Thank you very much for your attention. Now I hand over to Will, and we are happy to answer your questions.
Thank you.
Hello everyone, and welcome to our live Q&A session with ABB. As promised, I'm now joined by Mezid Ashnagaran, Global Product Line Manager, Electrification. Thank you, Mezid, for joining me today and for that very interesting presentation. I'm looking forward to getting started on some questions and hearing our audience thoughts.
You're welcome. Thanks to you, and thanks to everyone who joined today. We really appreciate your valuable time.
Great. Well, before we get started, a quick reminder that to take part in this Q&A, you just have to click on the Q&A tab on the right-hand side of the screen and type in your questions. As before, we will try and get through as many questions as we can in the time we have available, but any that we don't get around to covering will be passed on to ABB, and they'll be able to get back to you at a later date. Right, let's begin our Q&A. Mezid, what are the different components of electrification that members of our audience should be aware of, and what should they be doing to prepare for implementation?
Yeah, actually, for all electric mine, there is we need actually a new design. I mean, these days we are working on how it looks like a mine when everything is going to be electrified. And most of our customers already realize decoupling from the diesel is not the easy task. For getting the full value of the electrification, these days we need to actually create a kind of roadmap parallel to the mine plan. That is why that we need to work on a kind of customer and bring them a kind of different type and different option technology-wise that at the end help them. But how to start it, we always think that we need to have a kind of implementation of this electrification solution in a very cost-effective, phased manner. I mean, we should accept that, unfortunately, this electrification cannot happen overnight. It's a kind of a phased approach which needs time, that we come to a kind of hopefully a perfect solution for decarbonization. Before we more talking about a kind of single journey with a series of well-planned steps. That's why that this early engagement is quite important. Working very closely with the customer to break down their long-term roadmap and a strategy to a kind of short-term actionable project, piece by piece, step by step, and gradually transform their operation. The other important things is actually early involvement. We need to be engaged in the very early phase of the project, be able to do a kind of comparative simulation studies, a kind of techno-economical study for the customer in form of feasibility study or pre-feasibility study. We want to understand the particular mining operation. We want to provide a guidance for a strategic project decision, and also enable to customize the best fit for a particular mining task and operation. And that's why that this early involvement is quite important. And also these days when we talk about degrading of the ore. Degrading of the ore means that most of the new mines will be completely in remote area, far from the grid system, from infrastructure. Therefore, with the mines is completely in the remote area, located far from the grid. We need to also more and more integrate renewable energy and drive this green development. This. In addition, I can also say that integration of renewable energy and also bringing changes of energy supply chain. I mean, these days when we discuss with the market and the customer, a modern mine is only as strong as its energy supply chain. For building all electric mine requires also that supply fossil fuel energy and implement a storage system. We all know that unfortunately mine is 24/7 operation. We need to have also a reasonable technology solution for storaging of the energy. And this is also an area that these days we are seriously working on that. Therefore, integration of renewable energy and implementation of electrification solution, which is also work with the right storage system, which at the end create a kind of a stability and reliability for power system, because we believe in the future when electrification in the mine happens, the problem of the power quality will be more, while these days many mines are struggling with this topic. And that's why that this is also a very important element that we need to keep in mind.
Thank you, Mehzad. And we got a question from our audience here. Are you considering integrating the energy management system and the fleet management system, considering AHS operations into one system?
Actually, this is also one of the steps that we are working on that. Definitely energy management system is one of our pillars in automation that we are actually seriously working on that to be adaptable for this new all-electric mine, while we have for many years in this field quite active. Definitely fleet management is also an area that we would like to collaborate with the other actually technology providers, be able to at the end be able first of all to simulate the whole system, because electrification is not as traditional way of mining before. Therefore, we have now consumers which have started to move. I mean, each of these trucks, which in the future will consume 3 to 5 megawatt, they are also a kind of consumers that increase the entire power consumption in the mine, maybe in the double side. Therefore, managing this power in the form of being able to combine and create an interface between the fleet management and also management the entire energy of the mine is quite actually important, and these days is one of the area that we are quite active there.
Excellent. We've got a couple of questions asking about interoperability. Can you tell us more about the connection interface?
Yeah, actually, interoperability was from very first day one of the very important task that we had in the system, because we from very first day we said no one can do it alone. I mean, we have to collaborate with other technology providers, mainly OEM, in the way that we create a kind of open standard, fully interoperable for our customer. Therefore, for us, is quite important. Miners wants to have a kind of agnostic solution that is not actually bound or connected to one specific actually brand or one specific technical offering. We want to make it as easy as possible to integrate a kind of interoperable system open for everyone, for OEM, different type of the trucks, and also customer and other technology provider. Therefore, that's why that from very first day we talk about how we this joint development and co-creation actually play a crucial role in use of actually domain expertise of these technology providers and key partners to create a kind of interoperable solution, meeting a wider range of the needs, and also continuous alignment of the key technical suppliers will also help in the future that we are a bit closer to industry standards. One of the things that we are also suffering these days is that we do not have yet any standard, especially about when we talk about interfaces, and also when we talk about actually connectivity between truck and actually grid system. There's not a standard yet. That we have some platform that the OEM, the technology providers, and also the electrical supplier like ABB are working closely to create such a standard, which is still we are a bit distant to that point.
Thank you very much, Mehzad. Morton from our audience asks, when the shipping industry has changed to e-fuels, would it make sense to use e-fuels in the mining industry as well?
Actually, our focus is electrification, and that's why that we believe. I mean, how we can actually collaborate in this area of all electric mine, from mining point of view, and also we as a representative of actually a big group of the mining team of ABB, our focus is on electrification. We believe by expertise that we have in-house, we are able to actually fulfill the requirement of the actually mining operation in the future by implementing the all-electric mine solution. We actually cover it on their eMine platform. Therefore, we focus more on electrification part and leave the other actually optional solutions that the customer might use it in the future to other groups.
Thank you, Mehzad. A question from Christian in the audience. What should OEMs of battery-powered equipment consider in order to tie in best with ABB's ecosystem, e.g. a specific BMS or type of connector/plug?
Yeah. Actually, I should say that we are more or less independent from the all traction items and also battery system that we need to implement inside the truck, because we have inherited a kind of very nice portfolio from train system. Actually, our motion team in ABB are quite also active in this market to provide the all traction items in the platform of implementing inside the truck, including this very good solution for the battery system. Therefore, I should say we are more or less independent from any other third party to providing the entire solution. What we call it these days, grid to wheel. Also, I mentioned during my presentation, we strongly believe on the grid to wheel solution, because this connectivity and this continuous from actually grid system towards all elements and portfolio that you are implementing inside the truck will actually remove all the problems that later on either end user or also the OEM or truck manufacturer face as an interface problem. Therefore, it's well coordinated between grid system, supply of the power, and consumers item inside the truck, which is also one of our goal in eMine platform.
Excellent, thank you, Mehzad. Okay, I think we're kind of running out of time today, so I think this is a good time for us to draw things to a close. Thank you, Mehzad, for joining me today, and thank you to the audience for your questions.